The human ear is capable of hearing frequencies in the range from about 20 Hz down here right up to about 20,000 Hz, or 20 kilohertz, written as 20K. So everything audible in a recording falls somewhere in this range or thereabouts, and a given instrument or any other sound will occupy certain frequencies more dominantly than others. So for example, a hi-hat cymbal would have significant amplitude or volume from or between around 3 to 5K. So up here in the higher mids, but virtually no amplitude down here at 30 Hz. Likewise, a bass guitar will have a lot of amplitude around 80 Hz down here, but next to none up here at 10 kHz. So in other words, most instruments will have a dominant frequency range that constitutes the meat of the sound, if you will. Okay, so if you apply this theory across all the tracks in a mix, you can imagine how each instrument or voice will primarily occupy a certain range of frequencies. So this chart shows how a recording will be stacked in a perfect world. So the bass lives here, the kick just above it, then we got the piano and the snare, and nothing overlaps and everything's fine. And it would be great if it was that simple. Unfortunately, it's not. Each instrument will also occupy other frequencies in less significant amplitudes that make up some of the characteristics of the sound. So for example, the thump of a kick drum might be down here at around 60 Hz, while the click, that kind of might be up around 2K or higher. It can be way higher than that. Okay, so you see here from this chart the typical frequency ranges that each instrument can cover. So the bass drum goes right from very low to in fact quite high. The snare drum has the potential to get pretty low as well, and then you have that kind of crack. So you have the thump of it kind of down here, but the crack is up around here. So what happens is that these sound sources try to occupy overlapping frequency ranges. And if two sounds are trying to occupy the same frequency at similar amplitudes, so at similar volumes at similar frequencies, they're going to fight with each other, which creates a muddy sound and loses definition from both sound sources, which is a phenomenon known as masking. So we're going to have a look at one of the main tools for combating this issue of masking, which is the equalizer, also known as the filter. So we're going to take a look at two of the simplest filters to use in the next recording.